Hello everyone, I hope you all are very well. So, today is the last series of this lecture, that is the introduction to maps. Today is the part 4 conclusion. Part 1 to 3 I have covered all the details. In part 1 we have covered what is map, what are the fundamentals of map making. In part 2 I tried to cover that what are the different ways and what are the techniques of mapping, that what are the process you can do, what are the process you can adapt for map making. These things we have done. And in part 3 we have seen that different types of map, that based on our need, what are the different types of maps we have, and these things we have learned till part 3. Today is the last lecture of this chapter, part 4. Those who haven't watched the earlier videos, so my suggestion is that please have a look in part 1, 2, and 3, because those videos are very much important. Because if you go here to add directly, so it will be difficult for you to to recall and recapitulate all the things. So my suggestion is that please have a look in part 1, 2, and 3 videos. In those videos, all the detailed aspects of map making and fundamental ideas, core values has been mentioned. And I believe that before like this way you haven't studied any map, okay, that what is a map and all. So as map is a very fundamental part of geography, so please open your practical workbook, practical work in geography book, and in the last page you will get some information about this chapter. So today we will try to reveal that what are the different uses of map. We all know that why maps has been used. For example, based on specific purpose. For example, I want to do mountaineering, or I am an army person. So for me, topographical map will be the best option, because I have to understand the topography, the mountain plateau plains. For example, someone is a engineer and a planner, micro level planner, or a urban planner. For him or her, cadastral map is very much important. Someone is a geopolitical expert. He or she is making geopolitical policies, framing out some important policies. So he or she just need only the political map of India. Similarly, someone is a biologist or zoologist, belongs to life science background. So he or she will refer to the map of forest. Someone is a geologist. He or she will refer the rocks and mineral map. So for every purpose, different types of maps are there. So that based on the types of the map, we have understood that yes, for this type of thing, we need this kind of map. So if I generalized all the things, if I generalized all these aspects, first use of map, geographers and planners and other resource scientists use map in various ways. In your different professional aspects, maps has been used, and map has a very important role, because map plays a very important role. So many geographer, many scientists, they used to use map in different way. So if I say that yes, geographer, scientist, resource person, they use different types of map. In doing so, they make various type of measurement to determine distance, direction, and area. So three most important things in map are distance, direction, and area. In the previous class, I have already told you that, for example, to measure a distance, if I say that 1 kilometer of road, it is next to impossible for me to plot the entire 1 kilometer road in a map, because I need approximately 1 kilometer long map, a page, a paper. It is very difficult. Then what is the purpose of map? So I have to reduce it. But one thing you have to remember, that a reduction doesn't mean that in reality it should not match. But yes, in map, that I am reducing it, but I will reduce in a fractional way, that if I calculate the reduced part, I will have a relation, I will get a relation that yes, in ground this scenario is like that. So a reduction, we need some mathematical technique, we will learn definitely while doing some map calculation in this, in the class we will do definitely. After that, direction, we all know north, south, east, west, but between north and east there is few directions. Between east and west there are some, and this direction has been denoted by degree. So whenever we are maintaining or mentioning that yes, this feature is there, so many a times latitude longitude not only will play an important role, but also you have to refer these cardinal directions. And finally area, that yes, in this area or the area size is like that, particularly in this area only this feature we can found. So how to measure area, these are the important things. So measurement of distance, at first we will look over here. The linear features shown on the map fall into two broad categories, that is straight line and erratic lines. Erratic means zigzag line. So two types of line used to say, that is straight line. A straight line can easily be calculated by a ruler. If you placed a ruler, you get the centimeter value or inch value. After that you convert it according to map scale. This thing we can done. But for erratic lines or zigzag lines, a scale cannot work. At that time we need to use threads or a sophisticated instrument known as a rotameter. Rotameter, we have to, in a zigzag line, we have to place the rotameter, and we have to also zigzag this rotameter like this way, and the final reading we can get. I will show you the images. The measurement of straight line features like road, railway lines, canal is very simple. You can easily get it. It can be taken directly with a pair of dividers or a scale placed on the map. So if you have a divider, you can just take it and you can measure it. However, the distance are required more often along erratic paths. So erratic paths is very much important. That is the coastline or the river stream. These lines are very much important. The distance along all such features can be measured by placing a thread at the starting point and carrying it along the line up to the end point. The thread is then stretched and measured to determine the distance. It can also be measured by using a simple instrument called rotameter. So we can use a simple instrument which is known as a rotameter. This is an example of a rotameter. Okay, a wheel it attached like this way, and in this wheel you can see centimeters to kilometer written in this side, and on the top side you can see inch to mile, this is written. Okay, so we have to move accordingly. On the other hand, I have given you an image that if any feature is in a straight line, we can easily measure it in a straight line, no issues. But if it is in a curved line, then we have to make a thread and we have to measure the thread and ruler technique is very much popular. So whenever we will learn topographical map, because this is a very base and very much fundamental map for a geography student, we will definitely implies these ideas while learning topographical map. Moving on to the next point, measurement of direction. Direction is defined as a imaginary straight line, okay, on the map, showing the angular position to common base direction. So it will show an angular position. Whenever angular position is coming, that means indirectly I'm referring to the latitude longitude, because these are the angular positions only, and to the common directions. The line pointing to the north is zero direction or the base directional line. Particularly whenever the north line is there, approximately we used to say 360 degree, suppose. So many a times we used to convert 360 degree value to a 0 degree because we are referring north line. Whenever we will learn this concept, if field works we will go in different field work. So there are two types of north line. One is the true north, you can see like this, it will be a straight line. Okay, and in true north there is a concept of magnetic north also there. Okay, a magnetic north or north is little bit a deflected north. We will definitely learn this concept later on while doing a field work. We will definitely do this concept. The north direction enables the map user to locate different feature with respect to each other. The four commonly known directions are north, south, east, west. They are also called cardinal points. They are also known as cardinal points. In between the cardinal points, one may have several intermediate directions. So between the cardinal points, one may have several intermediate directions. So this is a engineer or surveyor compass. So I will suggest you to buy this compass for your betterment only, because this hardly will take 500 rupees or 400 rupees. It will not take much. Okay, this is a very important thing. You can have it, okay, later, because it is very useful in many purpose. This is an example of a cardinal that is points. You can particularly see there is north, there is east, there is west, and there is south. In between we have southwest, southeast, northeast and northwest, and again we have a further division here, like this small further divisions are there. So this is particularly the cardinal direction. The small divisions are precisely used to denote a precise location, suppose. Okay, and the same thing you can see I have converted in a degree based value, in a compass based degree based value you can see. So 0 degree I referred here as a north line, and all the degrees consecutive you can see. Okay, that northeast refers to 45 degree, after that east refers to 90 degree, southeast refers to 135 degree. So like this way you can see these cardinal directions. So these directions are very important. It will not required fully in class 11. This is a basic thing. In class 11 you don't need this, but for further studies, for example, those who want to pursue geography, those who want to do surveying and leveling, this kind of courses, those who want to do planning, those who want to do geology honors, so for them these concepts will really help you in different perspective. Okay, and the last important use of maps is the measurement of area. Measurement of area plays a very important role. The measurement of area of features like that of the administrative and graphic units is carried out over the surface of the map by map user. So many a time map user used to do is they used to calculate the area, because the main issue is that you are compressing or reducing a huge kilometers long area to a smaller size, and you have to maintain a lot of things, because in that area school is there, administrative building is there, shopping mall is there. So how you can represent it, as you are reducing 5 kilometer area to a 5 centimeter area, suppose. So it is very difficult. You have to maintain the precise size actual, the fractional size also, and the important points. Okay, so one of the simplest but not very accurate method to determine the area uh, is by means of regular pattern of square. In map, one thing you can see that a map consists of grids. Okay, in topographical map, in previous lecture in part 3 and in part 2, I have given a lot of examples that of topographical map and all the other maps. You have seen grid. Calculation of grid plays a very important role, and it really helps you, because a grid has a fixed value. A grid has a fixed value, and with this fixed value we can definitely help to gather the data, and what will be the area of that place, we can easily get it. In this method, the area to be measured is covered by square by placing a sheet of graph paper beneath the map on an illuminated tracing table, or by tracing the area into a square sheet. And the formula that we use is the area equals to sum of whole square plus sum of the partial square divided by 2 into map scale. So this is a generalized concept of how we can measure any area of a map. This thing we have to do practically. Okay, this formula is a practical application is also very simple, but practical whenever we will do the practical, you will understand the concept better. Okay, so while measuring something, while measuring area or something, we used to use instrument known as that planimeter. Okay, polar planimeter is very important instrument. You can see this is an example of a planimeter. So in this this instrument helps a lot. This line is a fixed plumb. Okay, it will not move. It's also known as a pole. Okay, here you can see in this image, it is also known as a pole. It will not move, and you have to be very specific for that. And there is a dial which will measure the area, and there is a tracer. Okay, this point is a tracer, so you have to move it in a clockwise way. Okay, no need to move it in anti-clockwise way, whatever. So you can get a data of the area. Okay, you will get a data of the area. You have to measure, you have to reduce the scale, and all this, some of the techniques are there. You can easily get the data. So that is an example of a planimeter. So finally, we have understood the use of map. Particularly, maps are used measurement of distance. After that, measurement of direction, and third is the measurement of area. I hope these concepts are clear. So please refer part 1, 2 and 3 videos. Those videos are very interesting. Today is the conclusion part only. So we have understood that why, how maps are used, and what are the key features of the maps that you can do. These are the some of the instrument that required for map making that I have displayed here. This instrument particularly required for, you can say, to find a fixed latitude longitude. After that, altitude. This instrument is very much useful. This instrument is known as theodolite. This yellow color instrument is known as theodolite. Okay. After that, to make a precise location and the distance between two important features, we used to refer this instrument. This is known as plane table. So plane table is very much important. After that, to measure a particular cardinal direction and the relationship with between the two directions, we used to use a prismatic compass. It's an advanced compass. Okay, this is a prismatic compass. After that, to measure the, you can say that, the land is leveled or not, what is the altitude of the land particularly. So this instrument we used to use, that is known as a dumpy level. Okay, that is known as dumpy level. So these are the instrument, and finally we have a small instrument here for mapping, to analyze the map, that is known as pantograph and a planimeter. So these are the examples of some of the instrument. You don't need to worry about this. These instruments are not there in your syllabus 11-12. This is a general introduction, that what are the techniques and how much hard work a geographer or and a surveyor they have to do to make maps. It's a very long process and a very delicate, very scientific process that geographers and surveyors used to follow. These are the specific instrument. So lastly, I would like to end this chapter with a beautiful note by from the American Association of Geographers, that field work. Geography is not merely a theoretical subject. You have to be very clear about it. If you are not comfortable of going outside or visiting the areas in different purpose, okay, doing field survey, so geography, I must say, it is not a subject for you, because you have to be very alert and very much enthusiastic to contribute in the field, because without field study, without observation, without investigation, a role of geographer is nothing. So field work is an essential ingredient of geography, because it provides a real world opportunity for students to develop and extend their geographical thinking. It adds value to the classroom experience. If I say you that, okay, this is a fold mountain, this is a fault mountain, in diagram only, but if you didn't visit the field, you'll not able to understand the concept. The outdoor is a resource for geographical learning, and fieldwork should be planned as a part of geography curriculum, not added on a special activity. So fieldwork is not a special activity in geography. It is a part of curriculum. Always remember this. Okay, so I will also try to do some fieldwork with you in nearby school campus. I will definitely try this. So a fieldwork is not a tour for geographers. It is an important activity. Whenever we need to understand something, or we to need more further definition, we have to choose fieldwork. Geography fieldwork is very much hands-on. When students are involved in fieldwork inquiries, they are collecting primary data, formulating questions to investigate, seeking answers to their question, and communicating their findings. So geographers is the only, more or less, person from a social science, there's those who collect primary data, and we have to help other social science background to derive their interpretation, because we used to collect a lot of primary data from fieldwork. Thank you everyone. Thank you very much for your time and consideration, and I hope you have enjoyed till this much all the chapters that I have completed. If you have any confusion, any problem, please let me know in the Google Classroom. The links are there, assignment links are also there. Try to solve the assignments are very easy, and my suggestion is that try to solve it, because don't keep your works pending, because I have seen a lot of things that pending works will make you you'll be in trouble, because a lot of work pressure will be for you. You have to complete these assignments and all. It will be very difficult for you. So enjoy learning, enjoy to be a geographer, and I hope in the class we will definitely study all the things very thoroughly. Thank you very much everyone. Thank you, and take care. We will meet in the next lecture. Thank you so much.